So let's go ahead and get started since we're going to be kind of on a tight timeline. But again, keep on popping onto the chat if All right, so we're going to have a couple of polls here real quick. And what I would like for you, if you guys could take a quick minute. Something just happened. So give me 1 minute here. There we go. So if you guys could please help answer this question, and I'm going to add a couple of more here. All right. See that we got that one, and we got one more that I want to put on here real quick. Just as we're waking up and everyone's kind of getting on here. All right. So if we could just take a few minutes or a few seconds and help answer those polls, I would deeply appreciate it. It just kind of helps give us an idea of how everything's coming along. There's one more. Oh, there's one more. So that one? Okay. I have assistant here. Lauren has been very graciously helping me out because, well, let's just be honest. I'm still on my first cup of coffee and hasn't kicked in yet. Still waking up, but she's always making sure that I'm on the right track. All right. So I'm just going to give one more, just a few more seconds about answering those questions, but this is great. Thank you guys for popping on and saying hello. Thank you so much. All right, so let's go to our, no, I didn't mean to do that. So what I'd like to do is just go ahead and get started here real quick. Again, my name's JJ. I've been an electrician for the past 25 years, doing industrial and commercial installations as well as audits. I've worked for Herzig Engineering for the past 4 years, for over a year in the field, performing the assessments for arc flash and electrical code audits, as well as teaching the classes. And then they transferred me to the office for more of an office role. So next, I would like to go ahead and ask a few questions, what we're kind of going to go over today, which is, what is the 70B, NFPA 70B, and who is it for? And why is it a standard now? A lot of these questions, my colleagues James and Caitlyn are going to help answer. So speaking of which, Caitlyn, James, good morning. Did I do that right? Did I said, hopefully I said that right. Good morning, James. Good morning, Caitlyn.
Good morning. Good morning. Let's see if we can get our here.
There we are.
Okay, so what I'm going to do real quick is James and Caitlyn, if you guys could take it over from here, and I'll pop on real quick is James.
All right, thanks,
Caitlyn,
JJ.
if you guys could take it over
Appreciate
from here,
you.
and then I'll pop on here in a little bit.
Getting us started here. Great to have everybody on here. Thank you for answering those poll questions. It looks like we have a pretty mixed group as far as level of understanding of what the NFPA 70B is and whether or not you've used it before. Most people do understand the difference between a recommended practice and a standard, though, so that's pretty cool. Appreciate everybody coming in and telling who you are and where you're from and all that. And so we'll kind of do the same here. So my name is Caitlyn Herzig. I'm an electrical engineer from UMKC, got my degree, 4-year degree at the University of Missouri, Kansas City. Graduated in 2019. And before that, I was actually interning with Herzig, doing some of the arc flash studies and data entry part of it. And then after I graduated, they let me actually start, reviewing work and making recommendations and stuff like that. As I continued on, I started to get some field experience, and part of that included learning how to give our trainings, and really kind of took off on that side of things. So now I'm the training programs manager, and I have my CESCP. James, you want to introduce yourself?
Hi, everyone. Thanks for joining us today. My name is James Weininger. I'm also one of the electrical engineers at Herzig Engineering, and I also went to the University of Missouri in Kansas City. Is actually where I met Caitlyn.
Yeah.
We both have a Bachelor of Science in Electrical and Computer Engineering. also intern with Herzig Engineering before I graduated, and ended up being an electrical engineer doing short circuit studies, building one-line diagrams, coordination studies, and arc flash analysis. And at this point, I've been with the company about 5 years, and I would say I've done a few hundred arc flash studies. And now I'm the electrical data analyst manager at Herzig Engineering.
Yep. And you're about to get your PE too.
Oh, right. Forgot to mention
Biggest thing of all.
So I can qualify for the PE license, or if anybody knows what that is, the professional engineering license here in a month. I've got all my references. I've passed both the FE and the PE exams, both the first try. So I'm really excited to, get that under my belt.
Big achievement. Big achievement. All right. So that's a little bit about us. Now let's get into the meat of why you're here. What did you sign up for? Well, this new thing that you want to know about, the NFPA 70B. So it is a standard now. And what we want to talk about is what that means and what it means for you guys, right? Yep. So first off, what is the NFPA 70B and why is it a standard now? We've kind of split this presentation into 3 modules, so to speak, 3 parts. So we're just going to get some foundation of what the heck this thing is, why it's a standard, and then we're going to move into some of the meat of the 70B and go through an example. And then we're going to talk about what you need to do right now to start getting compliant with it. So those are the 3 parts that we're going to go through. First off, what is it? Well, an important foundation of understanding what it is understanding how it fits in the world of code and standards that we already have for electrical equipment and safe work practices. Mm-hmm. So we have this kind of triad of books here with us. First and foremost is that National Electrical Code, the NEC.
Probably the book everyone's familiar with.
Yes, the NFPA 70. That kind of gets us started. And then we go to the 70E. And then we had the 70B for a long time, but it didn't really go in this circle because it wasn't a standard yet. It was a recommended practice, and we'll go into more detail about what that means. So we've got our installation requirements, our safe work practices and requirements, and then how to maintain the equipment for safety and reliability.
Exactly. Yep.
Exactly. So they all fit together to create a safer workplace and more efficient running of your equipment in general, which, both those things are very good whenever you're trying to run a business. But why do we care about this aside from just the logical side of wanting to keep people safe and keep your facility operational? Well, if we take a step back and look at what regulates these kinds of things, we often turn to OSHA. Mm-hmm. There's plenty of other regulatory bodies, maybe a local state OSHA run, or even the FDA or something like that could be more enforcing it. But if we look at OSHA, because that's kind of our backbone for a lot of these, is their 29 CFR 1910 subpart S regulation for their electrical standards. And in 303 of that 1910, there's a part called examination. And it says that electrical equipment shall be free from recognized hazards that are likely to cause death or serious physical harm to employees. So since arc flash, shock, electrical fires, anything that goes with electrical equipment, if it's not maintained well, is considered a recognized hazard, that's where we start to understand that maintaining your equipment does fall within this requirement of having it free from recognized hazards. Yep. Not maintained well can cause hazards. We got to follow this now. All right. So what's the difference between a code, standard, and a recommended practice? Well, essentially, they are broken out in different ways for very specific reasons. It's not just semantics. Some people use terms code and standard interchangeably. Not quite accurate. So recommended practice, it's only non-mandatory provisions. So the word should is used throughout it rather than shall, essentially. The best practice, it's something that you should strive to do, but nobody's going to be enforcing it, okay?
And something that I've noticed, Caitlyn, too, in recommended practices is outlining procedures and practices that you should follow that aren't necessarily mandatory. Yeah. And I've found that they're more thorough in the recommended practice, but once you get to the standard, you have to end up following rules, so it's less thorough.
Yeah.
So something that's happened in the 70B from it being a recommended practice to a standard for electrical equipment maintenance is that a lot of those practices that I found to be very beneficial have been actually stripped out in the new standard.
Sure. It's not in the required text portions.
Right.
Yeah. So yeah, with it being a standard now, all those shoulds or, would be nice to do kind of way of thinking about it are now shalls. It's mandatory.
Right.
And the way that it's written is in a form generally suitable for mandatory reference by another standard or code that's able to be adopted into law. So then we get to the code, which is suitable for adoption into law. It's required. So like the NEC, for example, is adopted in most every state from one edition or another, which references the 70E, for example. So the 70E has always been able to, or not always, but since it's become a standard, has been able to be enforced kind of through the fact that the NEC references it and the NEC is adopted into law into those states. So now that the 70B is, it can as well be referenced in that manner. All right, we got another poll question here. I'll go ahead and throw it up. Is all your electrical equipment maintained properly according to applicable codes and standards? You've already got it pulled up. Perfect. Yes, no, probably not, or good question.
That's kind of why you're here, is to find out, right?
Got
Or
a
at
little
least
over
get you
half
started
of you
on what you
answering.
need to do.
Awesome. We'll just give it just a couple more seconds and then we'll get rolling here. So quite a few of you are pretty confident that you have your equipment maintained according to applicable codes and standards, which is really good. And then a fair number that aren't sure or say no, probably not, which is fair as well. It's a lot of work to keep up with everything that our codes and standards say, and,
So
and we understand that.
Confidence and not really sure.
Yeah.
Yep.
But that's, of course, the goal, is to be able to keep it maintained with applicable codes and standards. Little side note there, if you maintain it with applicable codes and standards, such as the 70B, that also means following your manufacturer's instructions, because it specifically calls that out in the standard, and we'll get to that as well. We've got a question already. Can this slide deck be shared? Steve, that's a fantastic question. Absolutely. We will make sure that anyone who is in attendance gets a copy of what we're sharing today. Thank you for your question. All right, so real quick, just want to make sure that we understand what these three are, and hopefully that makes it a little easier to understand how this fits in that circle like we were talking about. So you want to talk about each of these purposes?
Sure, Caitlyn. So we can tell you all day long what these standards mean and their purpose, but let's dive straight into what it says in the codes and standards themselves. So in the National Electrical Code 90.2, the purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. This code is not intended as a design specification or an instruction manual for untrained persons. Key word is untrained, because how else do you design your equipment or install your equipment, right? Untrained people shouldn't do it. Trained people, however, should use the National Electrical Code as a design specification or an instruction manual.
Yeah. And then we've got the NFPA 70E, the standard for electrical safety in the workplace. And its purpose is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. So essentially, it outlines what safety program you need, training requirements, how people should be verifying absence of voltage, all sorts of wonderful things that you should be following.
Yep. And
then we get to the 70B now.
All right, you ready for this mouthful? So the NFPA 70B's overview and purpose is in 1.2. The purpose of this standard is to provide the practical safeguarding of persons, property, and processes from the risk associated with failure, breakdown, or malfunction in a means to establish a condition of maintenance of electrical equipment and systems for safety and reliability. Wow. That was a mouthful, wasn't it?
You didn't run out of breath, though, so it's fine. It's fine. So essentially, what it breaks down to is making sure that you have your equipment in a safe and reliable condition.
Right. I agree with that.
To summarize.
Sure.
So what does that mean? Well, if you don't, then you could have loss of production time, equipment failure, of course, which leads to that production time loss, or worse, causes injuries to personnel. You know, if equipment fails and it's a big enough failure that it could cause an arc flash, for example, and it blows the doors off, which we have seen, that could definitely cause injury, or worst case, loss of life. You know, maybe you have a grounding and bonding issue and somebody comes in contact with it and then all of a sudden they've gotten electrocuted. That would be absolutely worst case.
And something that we train in our electrical safety trainings is that loss of production time and equipment failure is, bad. It's important,
Right.
But it's not as important as safety for your personnel.
Absolutely. Okay, so where does the NFPA 70B apply? Now that we know we've got to install equipment properly, we've got to work around it properly, and we have to maintain it properly for safety and reliability, I'm going to put these two aside. Where does the 70B actually apply?
So the 70B applies to maintenance for electrical, electronic, and communication systems and equipment in industrial plants, institutions, and commercial buildings, and large multifamily residential complexes. Now, that's what it says straight from the code, but what I like to say is that everything except single-family residences.
Essentially, yeah, because that list is not all-inclusive. In fact, it says that the electrical, electronic, and communication systems and equipment typically found in those areas that James mentioned. That doesn't mean that those are the only places that this applies. Also note that it does say it should not supersede or duplicate the instructions provided by the manufacturer. So this should be used in conjunction with whatever the manufacturer still requires for maintenance and testing. Just following this does not mean that you're compliant with this, because it requires you to follow those documents as well. Very important note. So I've got another poll question for you. Do you have manufacturer's instructions for your equipment? I asked you earlier if you think you're maintaining it properly with applicable codes and standards. That means also with the manufacturer's instructions. So do you even have those available? Yes, no, only for some equipment. Okay, looks like a lot of people are saying yes or only for some equipment, which is totally fair. We've got about half the people answering, so let me give it a couple more seconds just so I see what we're working with here. All right, so a lot of people do have those manufacturer's instructions, which is great. You know, definitely make sure that you're using those and implementing them. That's the word, implementing them into your EMP or electrical maintenance program, a term that the 70B uses. And then for those of you who say only for some equipment, you should strive to find those manufacturer's instructions the best you can. And if you don't have it, then you can definitely rely on the 70B for those missing manufacturer's instructions that just aren't available. All right. Moving right along. So to recap kind of this first module, how it all fits together, a lot of people use this three-legged stool analogy. So the NFPA 70, or the National Electrical Code, is one leg. The 70E is another. And now the 70B is the third and final leg to make it a sturdy stool to sit your workplace safety and reliability upon, so to speak. So Steve says, in most cases where I did not have the OEM guidance, most times you can reach out and obtain them from the manufacturer. Absolutely. So if you don't have it on hand and that manufacturer still exists, you should be reaching out to them and having it provided. Yes. Thank you, Steve.
Yep. Great point, Steve.
All right. So that wraps up module 1. Now we're going to get into the nitty gritty. Module 2, what does the 70B entail? What does it cover? Well, we've essentially looked over these chapters and how it's organized now, which is totally different from the 2019 version, and broken it out into essentially 3 different chunks of material, for lack of a better word. Or I guess 4, because chapters 1 through 3 are also very important. It's kind of the housekeeping side of things that any good code or standard should have. Chapters 4 through 10, we would consider kind of the fundamental testing and maintenance requirements for all your electrical equipment. Chapters 11 through 38, actually, although 37 and 38 don't have anything in them yet, have the requirement details for specific pieces of equipment. So if you need to follow chapters 4 through 10 for all of it. Okay, now I've got this busway. What additional things do I need to do? Well, then you're going to go to chapter 14 and figure out what additional things you need to do. Or for your switches, same thing for chapter 17, so on and so forth. And then you have your annexes, which are not required. They're not mandatory. They're not part of the standard, so to speak, but they are incredibly good resources for you to build your maintenance program and check to make sure everything's good to go.
Yep.
Okay. So let's dive in. Chapters 1 through 3, like I said, these are kind of the good housekeeping of any useful code, standard, document, such
Right.
and so forth.
Yep.
So chapter 1 is the administration, making sure that you understand where this applies, what the scope of it is, what the scope doesn't cover. That's also important. Units of measurement that they use, such and so forth. Chapter 2 is really important as well. It's short, but it's important, making sure that you know what it's referencing. And then chapter 3, definitions. If you don't have a clear idea of what it's talking about specifically, you can go to the definitions and it should have that relevant term if it's something that's specifically used in here.
A lot of these definitions have been expanded to help match the 70E
Yeah.
and the National Electrical Code as well.
Yes. All right, so chapter 4. You want to get started with that one?
Sure. So first off, there's a wealth of new information in this standard. We're just going to be outlining some of the highlights.
Yeah.
Um,
I'm going to flip to chapter 4
Okay,
for you.
sure. So 4.2 is a big one. We have now what's called an electrical maintenance program, or EMP. Now, these must be implemented now and reviewed and audited no more than 5 years, right?
Every 5 years at a minimum. Yep.
Yep. And then in 4.3, you have personnel and what's called an EMP coordinator. So 4.3.1 states the EMP, or electrical maintenance program, shall identify an EMP coordinator. So Caitlyn, what do you think an EMP coordinator should do? It's kind of vague on what that means.
Well, yeah, we were looking to see if there was a definition, and there's not really a clear-cut rule on who an EMP coordinator should be. Logic kind of tells me that it should be somebody based on what they're responsible for.
Mhm.
It should be somebody that's qualified. It should be somebody that knows your systems and your equipment well and knows what it means to work on it safely as well, because they have to determine the scope of work for these kinds of tests and maintenance activities. So you don't necessarily have to, per what this says, but I would highly recommend somebody who's qualified, maybe already in a supervisory role, or someone that you know is highly knowledgeable and can handle that added responsibility.
That's just something that we recommend professionally, is that someone that's qualified to do this work should do this. However, it does not state such in the standard itself.
Right. And if you have a copy of the 70B, I would recommend you go ahead and grab it, because we're going to be doing an exercise later where we're going to flip back and forth and see how all these chapters fit together. Or if you have the link subscription, that's a good place to go as well. If you don't have either of those, you can make an account on NFPA and have free access. It's kind of cumbersome. It's not as good as the link, but you would still at least be able to see the code and standard breakdown of the different books that we're talking about. Anyway, so chapter 5, short and sweet, about personnel safety.
Right. So this is only about, 2 paragraphs here, but what I would think the reason for it being so short is that a majority of this information you would find in the NFPA 70E,
right?
The standard for electrical safety in the workplace.
Right. It's not going to reinvent the wheel here. It's not trying to copy paste what other codes and standards already have covered. And that's why 70E and NEC are mentioned in chapter 2 already. So it's just, hey, yes, you do have to make sure that those working on this and doing these tasks do it safely.
Right.
Go look to the 70E to figure out more. Okay.
Mhm.
Next.
So moving on, we have chapter 6, and being an engineer, this is probably my favorite chapter.
Absolutely. This is our bread and butter section right here.
So highlight the single line diagrams. You must have these, and they should be left legible and documented. You've got now short circuit studies, coordination studies, load flow studies, reliability studies, and finally arc flash studies, all of which should be reviewed for accuracy at intervals not to exceed 5 years. Now, you might be familiar with the NFPA 70E 130.5G states that the arc flash study or incident energy analysis shall be reviewed no later than 5 years, right? Mm-hmm. Now you have all these other studies that you must complete and review for accuracy at intervals not to exceed 5 years. So that's a big jump right there.
Yeah. Got to make sure that you keep those up to date. And that's for, again, equipment reliability and personnel safety.
Right.
Depending on what the study is.
And we do most of these studies at Herzig Engineering, single line diagrams. We send out our field techs to get that information from your system, and we model that in-house. We do the short circuit studies, coordination studies, low flow studies, and arc flash studies. I've done all of those myself personally.
Yep. And if you already have somebody doing that, or if you've got somebody in-house that's working on them, just make sure that they know to keep it all up to date every 5 years at a minimum to the highest standard possible, because it is about personnel safety.
Mm-hmm.
All right. And then chapter 7, fundamental tests. So it goes over the different basic things that every piece of electrical equipment should be tested to, whether it be making sure that you have the right tightness for torque verification, or contact resistance testing, make sure that there's not too much resistance, insulation resistance quality, as well as infrared thermography. There's a whole section about that, making sure that you are inspecting each of the sections of electrical equipment that have a tendency to cause the most issues in a facility.
Mm-hmm.
Moving right along to chapter 8.
Okay, so chapter 8 is field testing and test methods. And something new that's introduced here is testing category types.
Yep.
So you have categories 1, 1A, 2, and 2A. 1 just stands for that you can do this testing while the equipment is energized.
Yep.
2 basically means that these tests shall only be done while the equipment is de-energized.
Right. So they call it online standard tests or online enhanced tests. So the standard test you're going to do regardless. Enhanced test you do if you can't do the standard test, or if the standard test reveals a need to continue on and do an enhanced test. It's kind of the way that we've been reading and learning about this.
Yep. So also what's highlighted is what's called conditions of maintenance. So you have serviceable, limited service, and non-serviceable. So serviceable just means equipment that passes all tests and is electrically and mechanically sound shall be designated as serviceable. Limited service is equipment that has problems that are not detrimental to the protective operation or design characteristics of the equipment shall be designated as limited service.
Yep.
And then finally, non-serviceable is equipment that has a problem that is detrimental to the proper electrical or mechanical operation of the equipment shall be designated as non-serviceable.
Right. So you have to make sure you classify your equipment in certain ways in order to determine how often you need to do maintenance and whether or not you're even able to do that maintenance, or if it just needs to get replaced, essentially.
Yep.
Oh, chapter 9. Sorry, I'm getting ahead of myself. Chapter 9 is an important chapter that I'm sure most people are going to flip to immediately, is maintenance intervals. How often do you have to do this stuff? Maybe you already have an EMP of some form in place and you just weren't sure about the frequency, or it was just based on your own past experiences, or maybe just manufacturer's recommendations and you kind of populated that throughout. Well, this also gives some really good information about that. It's still based on condition of your equipment. So it talks about how often you have to do everything depending on the physical condition. So there's 3 different conditions that you could assign it. And you need to do a condition assessment. So condition 1 is essentially like new equipment. Not new, but like new. It's free of corrosion. It's clean. There's no issues with connections. There's no corrosion.
There's no previous maintenance
issues
that have been going on with it.
And you've had you have performed the maintenance tasks as they're supposed to be done. And then a couple pages later, we see condition 2 and 3. So condition 2 is where there's a potential issue that maybe the maintenance hasn't been performed as regularly as it should have, or you've missed the last cycle, or there's been some notification from your continuous monitoring system, if you have one.
Or your results from, let's say you worked on a piece of equipment and it was condition 1, and then you found later there was an issue that might elevate it to a condition 2.
Right. And then condition 3, you've missed successive maintenance cycles, at least 2 of them. So, you're supposed to do this thing every year. You haven't done it for 3 years. You're already in condition 3, technically.
Yep. There you go.
there's unaddressed notifications or urgent actions that you've identified. A lot of times we would call that evidence of impending failure.
So just from a visible inspection,
Yeah.
this equipment might be in a critical state.
Right.
For physical condition 3.
So those are kind of the different conditions that you would want to assess your equipment, and then you can apply how frequent you should be doing the different tasks identified in table 9.2.2.
Right. So depending on what condition you evaluate your equipment at, that will determine the frequency in which you maintain your equipment in the table that we'll be covering later.
Right. And we'll go through some of that information during our example or exercise, because right now we're just kind of spewing a lot of information at you. We'll try to give you a tangible example here too in just a moment. And then chapter 10 is additional requirements for hazardous classified location electrical equipment. So if you have a hazardous area that has those specific types of requirements for electrical equipment, these are just the additional things that you need to keep in mind for those pieces of equipment, regardless of what it is. Okay, we have another poll here. Have you been doing these kinds of studies, testing, inspection, and maintenance? Have you been following what this says as far as getting your short circuit analysis done, doing some visual inspections, making sure that it's all clean and everything's tight? Have you done infrared scans, such and so forth? Some but need to start doing others. Yes, we're rocking our EMP. Nope, but now I know we need to. Pretty good mix for these so far. About half of you guys responded. Which, kind of expected the most of them to say some, but need to start doing others, which is, fair. That's why we're bringing this stuff to light, making sure everybody's aware of what they need to do.
That's right.
All right. So the rest of the main chapters in the 70B are for specific pieces of equipment. So chapters, like I said, 11 through 38, I believe.
Yep.
So if you have followed chapters 1 through 10, 1 through 9, 4 through 9, whatever it is.
4 through 10.
Yeah. And you have a panel board that you're trying to set up a specific EMP procedure for. Then you're going to go to chapter 13 and make sure that you're following those as well. So there are still some reserved chapters in this as well. So like lighting control systems, electronic equipment, instrument transformers, and control power transformers. So they don't have any information in the standard yet, but it's reserved so that in future editions, if they have the ability to add that information, they can. And it's already organized so that it's all, laid out and you know where to look without having to bump a bunch of chapters around.
It's possible we will see some additional information added in the 2026 edition of the 70B.
It's pretty highly likely. I mean, this is, the first edition as a standard, and it has changed so much since the 2019. Kind of expect that there's going to be more changes.
What hasn't changed, Caitlyn?
Yeah, exactly. And then you get into the annexes, which have a lot of really good information for, like I said, guidelines, helping you build a better EMP if you don't have one, or if you have one and you want to make it better, like I said. One of the annexes that I really want to draw your attention to is the forms, Annex E.
Yep.
I think that has a lot of incredible resources in there. So if you don't have a panel inspection checklist or form already, for example, there's one back there. Tells you everything that you need to do, mostly, as long as you also add in whatever the manufacturer requires.
Right.
That's the only caveat there. So it's a good starting place if you don't have something, or if you have something already, all your checklists for your EMP program, go double check and see if there's one you're missing or could improve upon. They have a lot of good resources, but there's a whole lot in those annexes that are very important, and you should definitely familiarize yourself as well with all of it. I just wanted to highlight Annex E before we move on. Excuse me. All right. Now we're going to do our exercise here. So this is a fused safety disconnect.
3-phase fused safety disconnect.
That was actually from a project we did, we helped with, and we're going to use this as our example. So let's say we're going to create our EMP procedure or guidelines, policy, whatever, for this disconnect. All right, so with that, we're going to jump
for the fuses specifically.
Right, for the fuses in it. Okay, because there's fuses and then there's the switch and then there's all sorts of different things. So just focusing on the fuses, we're going to jump to chapter 16. All right, so chapter 16 has some information in there about what you need to do in addition to what the previous chapters already told us. And in fact, it says for frequency of maintenance, the frequency is based on what it says in chapter 9.
Yep.
So now we're going to flip back to chapter 9.
I got it right here.
Perfect. And we're going to figure out how often we need to do our visual inspection, cleaning, lubrication, mechanical servicing, and electrical testing. So where is that going to say?
So in table 9.2.2, you have the maintenance intervals. And in the leftmost column, you'll have products. And if you just go down to fuses, you'll see the scope of work you need to perform.
Yep.
Depending on the equipment condition, you'll have visual inspections, cleaning, lubrication, mechanical servicing, and electrical testing.
So based on this example, which condition, just gut instinct, and mind you, we haven't done a full assessment here with this one, but gut instinct, what do you think?
Well, I see some visible deterioration on the fuse blade and clips at the bottom right, on the C phase at the bottom. I also see a little bit at the top left.
Yeah.
So that would be a visual inspection there. So some issues or some corrective actions that I would need to take there. So I would probably classify that as maybe a condition 2 or condition 3.
Yeah. I was kind of leaning towards condition 3 as well, because if there's discoloration already, then there's obviously been some heating, right?
Yeah.
So that might have to have some components replaced. We don't know yet. Better safe than sorry until you finish doing all the other stuff, right? So for the purposes of this exercise, let's go with condition 3.
Sure.
All right. So what does that mean for each of those? Well, now this just became an every year task that you're checking on this. Now, if you check on it and you maintain it and you improve the condition, that's okay.
Yep.
There are guidelines for modifying how often you have to do this. So if you have a condition 3 equipment, like we're saying this fuse set is, and we perform our maintenance and do our visual inspections for XYZ period, and we're like, okay, actually this is now condition 1. We've really revamped this thing. Okay, you can make that determination, and that is also detailed in chapter 9 as well.
Yep.
Anyway, so we'll jump back to chapter 16. So we know we're going to do this every year. Visual inspection to start. It does break it out in low voltage versus high voltage, the typical cutoff being 1,000 volts for a lot of different standards. So 1,000 volts and less type equipment and greater than 1,000 volts. And we'll just look at that 1,000 volt and less because that's a 40 volt, wasn't it? I think a disconnect.
I don't remember.
Anyway,
I would
it's
guess,
low voltage for sure.
Yeah, low voltage.
So looking at that table 16.3.1 and pretty much almost every single chapter that has equipment specific inspections, cleaning, servicing, so on and so forth have tables like this. So check for discoloration.
Yeah, these tasks are specific for chapter 16 fuses.
Right.
11 through 16 has specific equipment and also has specific tasks for each piece of equipment that you'll need to follow.
A lot of them might be similar, but there are specific steps that you need to take for equipment that could be very different than what this fuses table says. That's a good point.
Yep.
So first one was just check for discoloration. That was the first thing that we saw, right? Yep. So that's one of them. Confirm that all fuses match even. You got to make sure that every phase has the same type if that's, the design that it's supposed to be.
Yep.
And that they are still the same from the last time you did the study. Because if you changed it, anything in that study could be called into question.
Right.
Okay.
Like if you change the fuse size,
right,
you might affect the arc flash study.
Right. And this goes all the way through 11 different steps, only 6 of which apply to the low voltage. Okay, so as we're looking at this, like we said, we have some visible deterioration and, it doesn't look to be in the best condition, all things considered.
It looks like they're using the same manufacturer and model of.
That is true, though. They do have the 3 different, or the 3
good.
Same on all different phases. And the ratings, if those are what I think they are.
I believe that's a FRSR fuse.
Yeah. And this is a low voltage application, so
Yeah.
we're good to go.
FRSRs are rated up to 600 volts, and assuming this is a 480 volt system, it should be rated for this system.
Yep. So that's an example of a quick visual inspection there. So then the next one is fuse cleaning. So clean the fuse terminals and clips if they've become corroded or oxidized. And then the second one only is applicable for greater than 1,000 volts.
Also to note, the testing categories as well. You've got one or
test
two.
types.
And on the screen here, you have clean fuse terminals for 1,000 volts or less. You have a test category of 2, which means you shall clean these fuse terminals while the equipment is de-energized only.
Yep.
Obviously, you don't want to be cleaning fuse terminals when there's energized conductors.
Right.
That doesn't make a lot of sense.
Right. For sure. Yeah,
Okay.
that's a very good point. It does tell you right there whether or not it should be considered online standard, enhanced, or offline
But
standard.
if you
and
go back
enhanced.
one slide, Caitlyn, previous slide. Previous slide. So you can see at the tasks that we looked at before, some of these tasks can be done while the equipment is energized or de-energized
Definitely.
with a test category of 1 or 2.
A lot of them, yeah.
Okay.
For sure.
All right.
Okay, and then the mechanical servicing, so just making sure that the fuse holder terminations are tight enough,
Yep.
for example, and then again, the other one doesn't apply to low voltage.
Tight enough, meaning they're tight according to the manufacturer's instructions, or if no data is available, you should refer to Chapter 9. There are tables.
7.
Chapter 7, I'm sorry.
Chapter 7, it's right here.
I'm getting those mixed up already, aren't I?
So torque verification, 7.2.1.4, .1 and 2.
Wow, it just keeps going, doesn't
Yes.
it?
Torque verification. So like James was saying, it does provide guidance in whenever you flip to that page in the standard, it has tables next to this, what you're seeing here, of what the different torque pressure or pounds per pound foot should be.
Pound feet
should be. How tight it is, essentially.
Yep.
And if it's saying just follow the manufacturer's specified instructions first, and if you don't have that, then go to these tables.
Yeah, that's very convenient.
And it's right there in that note, chapter 7. It said see chapter 7. So you see, even whenever you're in the specific chapter for fuses, as we're going through this example, it points back to previous chapters. Okay, so this one, perform
Electrical
infrared
tests.
thermography for electrical tests, measure fuse connection resistance, and fuse resistance itself. So we're actually going to do these in a little bit out of order. So real quick.
We'll be doing number 1 and number 3.
Yep. Real quick. I'm actually going to stop sharing my slideshow here. And you're going to have to look at just us for a moment. Okay. So essentially, real quick, and we don't have the exact same type of fuse. We just have a little 30 amp TRS fuse.
Yep. So we have a Cat 3 multimeter here, and you'll switch it to ohms, and we're going to be doing a contact resistance test on a fuse.
Yep. So if you'll hold the fuse for me as well. Thank you. Many hands make light work. So it's real simple. I mean, you literally just check to make sure that there's not excessive resistance.
And ideally, what you want to look for is between 0 and 5 ohms.
And if I stop moving, it'll not have resistance. Sorry.
But closer to 0, the better.
And we're at 0.1.
You can see that this is a good fuse right here.
So this one would still be considered.
But the fuses will vary depending on their model.
Yeah.
For their resistance values there.
So some of these tasks really do not take very long. However, that one would definitely be one that you do offline. So get it into an electrically safe work condition first, verify absence of voltage.
Pretty simple test.
And then you can check your fuses. Okay, and then the other one that we're going to highlight is performing an infrared scan.
Yeah.
Or thermography.
So that would be done with an infrared camera here.
Yep.
And we do infrared services at Herzig Engineering.
Yep. So
More information on that, actually, email me or JJ.
Yes, there you go. Shameless plug. 7.4, infrared thermography. So it does specify that you have to be able to see everything. So if you're just taking a scan with the door closed, not really going to help you.
Nope.
Or if you have an infrared window, even better.
You want to take direct measurements of the electrical equipment.
Yes, while under normal load. In fact, it says in 7.4.4, infrared thermography inspections shall be performed at normal circuit loading. If you can't do that, you're not going to be able to get the results that you need in order to have a valid infrared scan. So for this example, we have our fuses here, and there's the scan of them.
Yep. So before, just from a visual inspection, we saw some discoloration on the C phase at the bottom right, fuse knife clip connection point right.
Mm-hmm.
Now we can see from the infrared scan at the bottom right, because it's brighter, it tells you it's hotter than, with respect to the rest of the image, there's probably a high resistance connection there.
Yeah.
So what you would want to do, a typical recommendation is to de-energize, take the fuse out, clean the clip, and clean the knife connection point there, and rescan to make sure that helped alleviate any heating issues that you were seeing there. You can also see some heating in the top left on the A phase as well. So you'd want to check that same recommendation as well.
Absolutely. And Lisa, you asked how often do you have to have the infrared scan done? It depends. So it depends on the condition. It's every year.
If it's a condition 3, it's every year.
Well, that's one of the electrical tests, but for any connection point, there is a requirement for infrared scans to be performed every year, I believe. And then if it's in a condition 3, it's actually every 6 months. And I will take a moment to find that exact reference, but I've definitely read that before.
You're right,
Yeah.
Caitlyn. My apologies. In the same table we've been referencing,
it's right there.
at the very top.
At the very
it
top.
Says, all equipment shall perform infrared thermography. Condition 1, 12 months. Condition 2, 12 months. Condition 3, every 6 months.
Right. So an infrared scan minimum every year. We've been getting them every year. So Lisa, that would make you compliant with the 70B as long as you don't have any condition 3 equipment.
Yep. So we would classify this condition 3.
Mm-hmm.
So we would come in and scan it and find that you would make corrective actions, but you would still need to check it again in 6 months.
Yep.
If determined that, there's no more heating issues, it could escalate to a condition 1 or a 2.
We've got a really good question about the infrared study that I want to hold until the Q&A, just because I know we have some more stuff to get through. But Jack, I really appreciate your question, and James will go ham on it in just a few moments. Okay, so essentially, you can't tell that it is that hot. There's that big of a difference between the cold or the room temperature stuff and the heated point just by looking at it. So that's why you have to get that infrared scan done minimum every year. Okay, so to recap module 2, it's changed a lot since 2019. If you get a copy of this, or if you go online, there's a little in a shaded gray box to the left of everything that's new. And if you flip through it, like the vast majority have a little in next to it. I can't necessarily pull out anything that doesn't have an in, just flipping through it and looking at it right now, which means it's all new. You got to re-familiarize yourself with the structure of the document and what it all entails, because that's really the first step to getting compliant with it. Mm-hmm. And also just keep in mind, this is the first edition as a standard. It's not the first edition that this has been around, but as a standard it is. And so this is definitely not the final edition. It's going to have a lot of changes coming up. All right, so before we do module 3, just real quick, JJ's going to hop on here and give you a little rundown. Don't go anywhere, because we do want to make sure that you know how to move forward now that you know what this thing is.
Yes, Caitlyn, thank you so much. And guys, great job so far. Please don't go anywhere. We have a little bit more to go. I just want to pop on real quick and say we have a lot of experience performing what we're presenting to you today as far as the IR scans. You saw some of those pictures there that are like, well, it looked normal. And then all of a sudden, boom, there you go. I don't know if you can really see it too well. The camera doesn't really do it justice. I'm not very good at presenting that kind of stuff. But we do have extensive experience performing IR scans and the reports, as well as electrical equipment conditions. I've actually done one last year at a very high-end facility down in the, I think, Georgia area. And it was just something as simple. We're just pointing stuff out that they need to fix. Okay. We can help you with that, as well as arc flash assessments, single line diagrams, labeling, anything that happens with electrical safety. We want to assist you guys. Even if you have just questions about, like Lisa said, we've been getting this done every year. Do we have to have it done every year? That kind of stuff. Feel free to reach out to us. We want to help you guys move forward with electrical safety. So
Absolutely.
with that being said, I'm going to kick it back to Caitlyn and James, and then afterward we'll have a Q&A.
Perfect. Thank you so much, JJ. So yeah, if you have any questions, please feel free to keep populating those. I see, Steve, you also asked a question. Cody, you started to answer one, and we will definitely get back to that one for sure. Okay, so module 3, part 3, before we close it out, what do you need to do? So now you know it's a standard, you know kind of ish the format of it. I know it takes a while to wrap your mind around how it's all laid out now. So what should you be doing right now? Well, first and foremost, audit and update your current electrical maintenance program if you have one, and if you don't have one, get started.
Yep, get started for sure.
So what does that all entail as far as just saying audit and update it? Okay, that's a lot. Well, do an equipment audit and make sure that you have your conditions assessed. So doing a condition assessment of your electrical equipment. Figure out if it's condition 1, 2, or 3. Is it serviceable? Is it limited service? And make sure that you understand the different categories of tests that you can do. As well as audit your program itself and make sure that it is falling in line with what the 70B is saying that you should do and the frequency of it. Implement reoccurring condition assessments and tests of specific equipment at the frequencies outlined in NFPA 70B.
Yep.
So, and include
so it's important
those.
to get an actual copy. That would help big too.
A lot, yeah. Audit your employees responsible for electrical work and maintenance, because again, it does require you to have qualified people doing these tasks. You don't want somebody performing an electrical task and getting hurt or killed trying to follow what you're telling them to do, but they don't know how to do it safely. So they need to be qualified per the 70E. And lastly, assign that EMP coordinator, or maybe that's first. Maybe that's first. Get somebody in charge of this initiative.
Yeah.
Somebody who knows your equipment, knows your facility and your systems, and has enough of a technical understanding of what these 3 codes and standards say to implement the 70B effectively, as well as know who to reach out to if you don't have the manufacturer's instructions.
Yeah, so an EMP coordinator might be a maintenance supervisor
It very well could
or
be.
a EH&S type person.
It could be, but it doesn't have to be. Let's say you've got an electrician that's been there a long time and he or she is showing real leadership skills. They might be a good fit for an EMP coordinator if that's what makes sense for you guys. So, all right. Before we close and do our Q&A, I have one more poll question just to make sure we're all on the same page. When talking about electrical equipment maintenance, what is the most important factor? We got to keep our production going. So production economics, equipment loss, it's expensive to replace it, which is true, or personnel safety.
Well, that was a weird beat.
Hold my breath here. Everybody so far has been saying personnel safety. We got one person saying equipment loss. All right. It's personnel safety. You can't have a business run effectively if somebody gets hurt. And so safety is always the number one factor, even if you're worried about production time and not having downtime, and you've got all these hopefully metaphorical fires in your workplace that you have to put out.
Right.
Safety is still the number one priority. So that's why it's written the way it is. And that's why 70E is also an integral part of that triad of codes and standards. Okay. So just make sure that we all keep on the same page. Safety is the most important factor. Okay. And with that, let's hop back to the questions. So thank you so much, everybody, for attending. If you have questions, please feel free to type it out into that chat box and we will get rolling in here. So Jack, let's go back to your question first. Or did JJ have something to say first? My bad. Okay. So Jack, do you need to know the exact temperature, or can it be whatever it displays? And Cody actually started to answer the question a little bit here. You will need to inspect and compare like components, check A, B, and C phase on the line side and load side while comparing the max temperatures, and see the difference between, as in other words, the delta, the difference in temp between each component, each like component. So do you want to add anything to that?
So Jack, something that's really important that's taught to you in your certification class is to try and get the exact temperature as best you can.
Right.
Now that's important. It's sometimes time consuming, especially considering the 70B is now expanded and you must now follow most of it.
Yep.
However, the 70B does not state you should use the exact temperature. It does state that similar electrical components under similar loading shall be compared for their temperature, and then comparison between electrical components and ambient air temperatures. So if you have, in reality, that three-phase fuse disconnect that we saw, ideally we look at an electrical load that's balanced across all three phases, right? Unless you do a current or a load test on each of the phases to make sure they are balanced. But assuming they are balanced, you'll see a high resistance connection in the bottom right compared to the other two. And according to the 70B, we're comparing similar electrical components under similar loading. And looking at the bottom right, there's an issue, obviously, compared to the other two phases.
Right. In order to get an accurate delta, you should be able to have specific temperatures, I think is the summary of that question. Okay. Next question.
Real quick, if you don't mind,
Sure.
I don't want to get too lost. Lisa had asked a question. How often do you have to have the infrared scan done?
Oh, yes. So we did answer that. It's every year or every 6 months if you have condition 3 equipment.
Okay.
Thank you.
Thank you.
And Steve asks, what frequency will NFPA update the 70B? Is it like the 70E every 3 years?
What was the question again?
What frequency will the NFPA update 70B? Is it every 3 years like the 70E?
So from what I've heard from someone at the IEEE Electrical Safety Workshop this year in Reno was they were trying to follow the 3-year pattern that the NFPA 70E and the NEC follows. So we should expect a new edition of the 70B in 2026.
That would make sense, yeah. As long as they are able to follow that, which I believe they're trying to. Okay, any other questions here?
Don't be shy. You
Yeah,
can just
feel
go ahead
free.
and just type them in right there.
Okay, have you seen any software, Cody's asking, have you seen any software for tracking the 70B inspections that work well? Are we still in the create a spreadsheet and take some pics phase?
That's a good question.
That is a good question.
Whenever I go on site and do electrical safety audits, I haven't dove into the PM side of it too much, but I know that there are some softwares out there that make it really easy, and you can, it's kind of like an app. You go on and you've got your picture of your equipment and you've got your PM, and it links to your internal codes and standards or policy documents that you need. They do make stuff like that.
So I don't personally.
I don't know
have
what they're called,
EMP
unfortunately.
Experience building a program. However, Kyle Smith, one of our directors, has lots of experience with that, and he can make recommendations for software for tracking these types of things. So if you want to email me later, I can follow up and give you some recommendations on what you can use.
Yeah, Cody, we'll follow up whenever we get some names specifically to drop.
He told me a few days ago one of the softwares, but it's already slipping.
I know,
my mind,
it's one of those things. I have a really nice template on Smartsheet. Oh, Steve, that's fantastic.
Awesome,
if you're
Steve.
willing to share that resource, I think we all would be incredibly
That'd be
thankful.
awesome, Steve.
It's wonderful whenever we can pull together and share resources like this. Anytime we can make it easier to keep people safe and equipment running, right?
That's what's great
That's
about
right,
this
Steve.
community is
Yeah.
people sharing to making sure everyone's compliant and safe.
Yep.
Okay, so we have time for one more question, and kind of like a pre-made question per se.
Oh boy.
Okay. So Let me pull it up here real quick. All right.
So if you guys have any more questions, definitely feel free to reach out to us. There it is. There's our contact information. You can always call the office and ask for one of us, or JJ, or really anybody should be able to get you to the right person to get your question answered. You can also email James or I directly. We've got our emails on the screen there. It's just our first initial, last name at herzigengineering.com.
Hit me up.
Absolutely. Answer the tough questions. Hop on a call. Really pick our brains.
Yep.
It'll be good for us as well.
Exactly.
Okay, so do I need to have the IR scans or services to remain compliant?
Yes.
Simple answer, yes. Since the 70B is a standard now, when it's going to get enforced or how it's going to get enforced is still a question mark. However, that is an eventuality, right? And it is something that you should be prepared for. So to be compliant means following the recognized codes and standards. So yes.
So we can give you our opinion, but what does the code say or the standard say? 7.2.1.1 infrared thermographic inspection of electrical connections. Infrared thermographic inspection of electrical connections and terminations shall be performed in accordance with section 7.4, and 7.4 just is the infrared thermography section.
Right.
So you shall perform it.
And if you look at table 9.2.2, it says minimum every year.
The frequency. Yep.
Yep.
All right, guys. Well, what we're going to do is that we've got some other questions here, but we're going to have to wrap it up real quick. We are going to reach out and help you guys out. Glenn, Steve, yes, we're gonna send this to you guys and help answer your questions, but we do need to come off of here. Again, thank you so much for attending this webinar. If you have any questions or would like to inquire more about how we can help you out, please feel free to reach out to me, Caitlyn, or James. We'll get you taken care of, whether it's the IR scans, preventive maintenance, what have you. When it comes to electrical safety, it is our obligation to make sure everyone tries to go home in a safe manner.
Absolutely.
All right. So again, on behalf of James, Caitlyn, thank you guys so much. You guys did great.
High five,
today.
Caitlyn.
Yep, high five it. All right. I'll high five myself. And so thanks to guys, and we'll talk soon.
And just real quick, there was one more. Will this chat stay active? Is there any reason we can't leave it open for a couple more minutes? Because people are sending each other their emails here. So let's leave it open for a couple more minutes. We're going to hop off, but you guys go ahead and copy paste those emails, and we'll close out in another 5 minutes or so. All right. Thanks, guys.
Thanks, everyone, for
Thank you,
attending
everyone.
today.